Why does fire exist? It sounds like a simple question. You've seen fire more times than you can count. Campfires, candles, kitchen stoves. You strike a match, and suddenly, flames bloom into existence. But why does that happen? Most people never stop to ask. Fire just is. It's hot. It's bright. It destroys things. End of story, right? Not even close. The moment you seriously ask what fire actually is, what's truly happening when something burns, you uncover something unexpectedly beautiful. Something deeply connected to how nature works at every level. And once you see it, you can't unsee it. Fire isn't just an event. Fire is a window into how atoms behave, how energy flows, how the sun powers life on Earth, and even why trees exist at all. Let's start at the beginning. Picture a piece of wood, a fallen tree, lying still, doing absolutely nothing. Now picture the air around it. Oxygen drifting invisibly, also doing nothing. The wood has been there for years. The oxygen has always been there. They coexist, side by side, and yet, nothing happens. Why? Because atoms don't all get along the same way. Oxygen atoms, for example, are very attracted to carbon. When they get close enough, they lock together instantly. And when they do, a huge amount of energy is released. But here's the catch. If they aren't close enough, they actually push each other away. They collide, bounce, and separate, never realizing how much energy they could release if they just got a little closer. That's the tension at the heart of fire. Carbon and oxygen want to be together. That bonded state is more stable, lower energy, more comfortable for the universe. But reaching that state requires effort. They have to cross an invisible barrier first. Think of it like a ball rolling across the ground toward a deep pit. The pit is where it wants to be, but there's a hill in the way. As long as the ball doesn't have enough speed to climb that hill, it just keeps rolling past, again and again. That's exactly what's happening here. The atoms are moving. They're colliding millions of times every second. But without enough energy, they never make it over the hill. So everything stays exactly the same. The ball never drops into the pit because the moment it starts climbing the hill, it loses speed and rolls back down. But give it enough momentum, make it move fast enough, and it clears the hill and disappears into the hole. That's exactly what's happening with wood and oxygen. Inside the wood is carbon, captured long ago by a living tree. Oxygen drifts through the air and slams into that carbon constantly. But at normal temperatures, those collisions aren't energetic enough. The oxygen hits, rebounds, and flies off again. The air keeps moving. The collisions never stop. Millions upon millions every second. And yet, nothing happens. Atoms collide, bounce apart, and repeat this dance endlessly. The wood remains unchanged. The oxygen keeps floating by. No flame, no heat, no light. This can continue for years, for decades, even for centuries. A piece of wood can sit surrounded by oxygen for 1,000 years and never burn. Not because the atoms don't want to react, but because they can't cross the energy barrier standing in their way. But now imagine adding heat. Somewhere, somehow, a few atoms get moving faster than the rest. A spark, a match, a sudden rise in temperature. Those faster atoms finally make it over the barrier. They get close enough, and they snap together. That single reaction releases energy that shakes nearby atoms, making them move faster too. Those energized atoms slam into others, pushing them over the barrier. One reaction becomes two become four become eight. Each reaction creates heat. Each burst of heat creates more reactions. The process feeds on itself. Within a fraction of a second, the number of reacting atoms explodes. Billions of bonds are forming all at once. Carbon and oxygen are snapping together everywhere, simultaneously. That sudden, violent cascade, that runaway chain reaction, is fire. Nothing mystical happens when you light a match. You're not creating fire out of nothing. You're simply giving a small group of atoms enough energy to get over the hill. Once they do, the rest follows automatically. Energy is released. Atoms move faster. More reactions occur. Even more energy is released. It's exponential. A feedback loop. A chemical avalanche. That's why fire doesn't slowly fade into existence. It erupts. And all that snapping, all that bonding, all that released energy turns into motion. Atomic motion. Jiggling. And that jiggling is heat. Now imagine placing a cup of coffee above all that atomic chaos, above the snapping bonds, above the rushing reactions. The coffee heats up because its atoms start jiggling faster. That's all heat really is. Heat isn't a substance. It isn't a liquid flowing from one object to another. Heat is motion, tiny particles vibrating, colliding, and speeding up. The faster the atoms move, the hotter something feels. When fire releases energy, that energy doesn't vanish. It goes straight into motion. Atoms shake harder. Molecules vibrate faster. Temperature rises. That warmth you feel when you hold your hand near a flame. That's atomic motion reaching you through the air. And this is the crucial idea. Fire is not a thing. Fire is not a material. Fire is a process. A violent, self-amplifying chain reaction where atoms bond faster and faster, releasing energy that drives even more reactions. One bond forms, energy bursts out, nearby atoms speed up, and suddenly, more bonds can form. It's a cascade. Once it begins, it sustains itself. The heat produced by the reactions provides exactly the energy needed to keep new reactions going. That's why flames spread. That's why fire races across dry wood and leaps from branch to branch. The loop feeds itself. Heat makes atoms energetic enough to react. Those reactions create even more heat. That extra heat triggers even more reactions. Round and round it goes. A feedback loop in its purest form. And the only way to stop it is to break that loop. Cool the system below the critical point. Remove the fuel. Cut off the oxygen. Take away any one side of the fire triangle. And the entire process collapses. Now, once you start thinking this way, it's hard to stop. You begin to ask deeper questions. Why did this wait so long to happen? Why did the wood sit there for years, surrounded by oxygen, without burning? And more importantly, where did this combustible material come from in the first place? The answer takes us back to a tree. Because the substance of wood is carbon. And that carbon came from somewhere else entirely. That carbon comes from the air. Specifically, from carbon dioxide floating all around us. Most people look at a tree and assume it rises out of the ground. You plant a seed in soil, water it, and a tree appears, so it must be made of dirt, right? That idea feels obvious. And it's completely wrong. This is one of the most beautiful misunderstandings in all of nature. Trees don't come from the ground. They come from the air. Carbon dioxide enters the leaves, and inside the tree, something remarkable happens. Using energy from sunlight, the tree tears the molecule apart, pushing the oxygen away and keeping the carbon. That carbon becomes the solid substance of the tree. Water joins in too. It comes up through the roots, yes, but where did that water originate? From rain, from the sky, from the air. So when you really look at it, almost everything that makes up a tree comes from above, not below. Only a tiny fraction comes from the soil. Those minerals, the trace elements absorbed by the roots, are what remain as ash when wood burns. That pale residue left behind in a fireplace? That's the ground. But the wood itself, the part that crackles, glows, and turns into flame, that came from carbon pulled out of the air and water that once fell from the sky. Nearly all of a tree's mass is air, made solid. And we can prove it. Take a pot of soil and weigh it carefully. Plant a seed, water it year after year, and let a tree grow tall and heavy. Then dig the tree out and weigh the soil again. The soil weighs almost the same as it did at the start. Maybe slightly less, just a small loss of minerals. Yet the tree now weighs hundreds of pounds more than the seed ever did. So where did all that mass come from? Not from the soil. The ground didn't lose hundreds of pounds of material. The mass came from the air. This isn't a guess. It was tested. Back in the 1600s, a Dutch scientist named Jan Baptista van Helmont set out to solve this exact mystery. He carefully weighed a pot of soil, planted a seed, and watched a tree grow for years. When the experiment ended, he weighed everything again. The result was stunning. The soil had barely changed. The tree had gained an enormous amount of weight. Van Helmont correctly realized that the tree wasn't made from the soil, but he assumed it came mostly from water. He was close, but not quite there. Water plays a role, yes, but most of the mass comes from carbon, pulled directly out of carbon dioxide in the air. And that raises a deeper question. Carbon and oxygen bind together very tightly. So how does a tree manage to pull them apart so easily? Is life using some mysterious force? No. The answer is simpler and far more powerful. The sun is shining. Sunlight pours down onto leaves, and that energy is used to pry oxygen away from carbon. It takes real work to do this, and the sun provides every bit of that energy. Photon by photon, it breaks carbon dioxide apart. The oxygen, the plant doesn't want it. It releases it back into the atmosphere as waste. What remains, carbon combined with water and other molecules, becomes the solid structure of the tree. This is what makes life on Earth possible. The sun isn't just warming the planet. It's doing real physical work, injecting energy into the system, pushing matter away from equilibrium, creating order out of chaos, and building structure where none existed before. Trees do this constantly. They inhale carbon dioxide. They tear it apart. They build themselves from the carbon, and they release oxygen back into the air. That process is called photosynthesis. And here's the beautiful symmetry. Photosynthesis is nature undoing what fire does. Fire forces carbon and oxygen together. Trees use sunlight to rip them apart. Fire releases stored energy. Trees capture it and lock it away. Same ingredients, opposite directions. The tree uses sunlight to do work. Real work. It captures energy, stores it, and turns it into structure. And that structure is nothing more than potential energy made solid. Carbon and oxygen are being held apart. They want to reunite. They naturally prefer to be together. But the tree forces them to stay separated, and that separation stores energy. Now take that structure, the wood of the tree, and place it in a fireplace. Surround it with oxygen, most of which was released by trees just like it. Carbon and oxygen, once torn apart by sunlight, now sit side by side again. They're eager to reunite. All they need is a trigger. Add a little heat, and the process begins. Carbon and oxygen rush back together, releasing enormous amounts of energy as they do. The structure built by the tree starts to collapse, and in that collapse, motion erupts. Light pours out. Heat floods the air. The process is being reversed. Carbon and oxygen are recombining into carbon dioxide. What the tree spent years building is being undone in minutes. And the light and warmth you see, the glow of the flames, that's the same energy that once arrived as sunlight. Burning wood is releasing stored sun. Pause for a moment and really think about that. A tree spends years collecting sunlight, one photon at a time. It uses that energy to pull carbon from the air and slowly assemble itself. Every ring in the wood is a record of captured sunlight. Then the tree is cut down. The wood dries. It's stacked and stored. And when it's finally lit, all that saved sunlight comes rushing back out. The carbon that took years to separate from oxygen collapses back into its preferred state. The energy locked inside those bonds is released in a sudden cascade. Fire is sunlight set free. A burning log is the sun shining again. The flickering light in the flames? That energy fell on leaves 5 years ago, 10 years ago, 50 years ago, stored quietly in chemical bonds, now released all at once. Every photon in a flame is, in a sense, recycled sunlight. The energy hasn't changed form. It entered as light. It was stored as structure, and it returns as fire, which leads to an obvious question. If carbon and oxygen are so desperate to be together, why doesn't wood just burst into flames on its own? Why do you still need a match? Remember that hill we talked about earlier? That's what scientists call the activation energy. At normal room temperature, the atoms just aren't moving fast enough to get over it. They collide, they bounce, but they don't react. Wood and oxygen sit in what's called a metastable state. They want to react. They want to release energy, but they're stuck. It's like a boulder perched on top of a hill. It wants to roll down to the valley below, the lower energy state. But right now, it's resting in a tiny dip at the summit. Stable, until something nudges it. Give it just a little push, and down it goes, releasing a torrent of energy. That's what a match does. It provides the nudge. A tiny patch of wood heats up, atoms start jiggling faster, some finally get over the hill. Those first reactions release heat, which energizes neighboring atoms, and soon the fire spreads. This is why wood doesn't just spontaneously combust. The universe is full of metastable states, systems that want to release energy but can't start on their own. Wood and oxygen, gasoline and air, even the food in your cells reacting with oxygen. They all sit there, waiting for a spark, a heat source, or a catalyst. Once the trigger comes, the reactions run on their own, unstoppable. And here's another mind-blowing fact. The oxygen in the air, where did it come from? From trees, from plants, from photosynthesis. For billions of years, plants have been breaking apart carbon dioxide, keeping the carbon to grow themselves, and spitting oxygen into the air. All the oxygen you breathe, all the oxygen in the atmosphere, it's waste. It's a byproduct. Plants don't want it. They release it. They throw it away. In the early Earth, there was almost no free oxygen. The atmosphere was thick with carbon dioxide, nitrogen, and water vapor. Then photosynthetic organisms evolved. Slowly, they started dumping oxygen into the air as waste. For these early life forms, oxygen was poisonous. Many of them died as oxygen levels rose. But some adapted. They learned to use oxygen to burn food and extract energy. And that very oxygen, produced by plants as unwanted waste, is exactly what makes fire possible. Here's the cycle. The sun shines. Plants capture that sunlight to split carbon dioxide apart, building themselves from the carbon and releasing oxygen back into the air. Animals, humans included, eat those plants or eat other animals that have eaten plants. Inside your body, the carbon combines with oxygen, releasing energy in a controlled process called respiration. It's the same chemistry as fire, just slower, more precise. You're taking carbon-rich molecules, combining them with oxygen, and releasing energy. The carbon dioxide you exhale? It's the same carbon dioxide the plants once absorbed. Sunlight becomes plants, plants become animals, and energy flows. Carbon cycles, oxygen cycles, life flows. Fire is just that cycle made visible. When you burn wood in a fireplace, you are performing the same reaction your cells do with sugar. Carbon plus oxygen forms carbon dioxide, releasing energy. The only difference is speed. Your cells do it slowly, capturing energy carefully in molecules like ADP. Fire does it all at once, releasing that same energy as heat and light. Same chemistry, same process. In a very real sense, you are a slow-moving fire. And to make this even more tangible, when you burn wood, you're transforming stored chemical energy into heat and light. That energy was locked in the bonds holding the wood's molecules together. Those bonds weren't free, they took energy to create. That energy? It came from sunlight the tree absorbed over years. When the bonds break and new ones form, carbon dioxide and water, the energy is released. The heat you feel? That's atoms moving faster, jiggling more because energy was unleashed. The light you see? Atoms and molecules getting excited. Electrons jump to higher energy levels, then fall back down, releasing photons. That flickering glow is literally energy changing form, the fire you see. Different atoms glow in different colors. Sodium burns yellow. Copper burns green. Strontium burns red. That's why fireworks dazzle us. Different chemicals, different electron configurations, different colors. And the smoke you see? Tiny carbon particles and other materials that didn't fully react. Hot, less dense, they rise into the air. The ash? That's minerals, the tiny fraction of the tree that actually came from the soil. Everything else, the carbon, hydrogen, oxygen, has turned into invisible gases, drifting away as carbon dioxide and water vapor. The mass isn't gone, it's just changed form. And here's the question that should blow your mind. If fire is stored sunlight from trees, if energy is moving, jiggling, leaping from atom to atom, then how is the sun itself so intensely jiggly, so hot? That's a story for another time. But before I stop, here's something to imagine.